That we are right on schedule. Our next presenter this afternoon is Brandon Delis. He was Strategic Water Programs Leader for Duke Energy, and he's going to talk to us about challenges of the proposed effluent guidelines, and I think that's a fancy way of saying water. So I think we will hear about some of the things we heard about this morning, so come on up.
Good afternoon. Everybody hear me in the back okay?
Just tip that mic up a little bit.
Is that better? Yeah, I do. I'll do great with microphones, so I'll do my best here. So start out first with kind of the company line here. I work for Duke Energy. Most of you probably understand or know what Duke Energy is. These are a bunch of numbers. I won't go through the numbers. In general, we're a very large utility. We cover a number of different regions. Midwest, General Carolinas, and then in Florida. I would say that if you look at our fuel mix across the entire company, it's about a 1/3 nuclear, 1/3 coal, 1/3 gas, but that doesn't always tell the whole story. You kind of have to look jurisdictionally. So one thing in the Midwest and Indiana, we're really heavy coal. In Carolinas, we've really worked over the last few years to be kind of really a good blend, so that's probably our most balanced jurisdiction. And then in Florida, we're kind of heavy gas. Only have a few coal units left there. So it kind of speaks to, yeah, we're a balanced company overall, but we have that fuel mix challenge, which a lot of folks talked about throughout the morning. So this morning, a lot of great discussion, a lot of high-level, fleet-level type stuff. I think we're going to try to take it into some more detail to piggyback on what Mr. Shea said. I'm an engineer, not a lawyer. So I'm going to do my best to focus on the technical aspects. But what I did want to do is, as I go through the effluent guidelines, we commented heavily on this rule. We have a lot of unique experiences to offer. So what I wanted to do today is to kind of outline some of Duke's comments as it related to the rule and how it was proposed. So hopefully you guys find that valuable. Hopefully it sparks some discussion. So I'll talk about the rule. Talk about what a typical power plant impact might look like. Then I wanted to narrowly focus on two areas, FGD wastewater treatment and the compliance with effluent guidelines combined with the CCR rules. So there's really a link between those two related to ash management, and I wanted to highlight those as well. So I won't touch on every bit of the rule. You'll get a flavor, but hopefully I wanted to focus on those two things because they're probably the most important or probably the biggest impacts. So water compliance at a facility related, compliance with NPDES permits, what does that look like for sites? We put together this kind of diagram, and I originally put it together just to help me understand it because it kind of can be hard and confusing. But there's three areas you need to focus on. One's water quality standards, so that's your general human health. There's agricultural standards, aquatic life standards, and then other regional standards. An example of that here would be the Great Lakes Initiative, or maybe Orsenco along the Ohio River. So those kind of set a certain limit. You've got anti-degradation, so that's based upon the water body that you're sending it to. Are you meeting de minimis thresholds into the water? So basically, are you impacting the water you're discharging to? And then the third is the effluent guidelines, which basically sets a technology-based limit, the best available technology economically achievable, sets a limit that basically is a federal standard. So you mix those three together, and ultimately whatever is the most controlling or the smallest will ultimately lead to your NPDES discharge. And that last point is that the order can be different at each site. The order can be different at each site within the site depending on the constituent. So you have to see all three. And what this does, it makes NPDES compliance very site specific. So there isn't a fleet-wide approach to any of this. I get a lot of pressure from my management. It's like, well, what's the standard box? What are we going to build? It's like, well, it's not that simple. So the effluent guidelines, I heard a gentleman before saying he was struggling with the acronyms. I'm going to probably throw a lot of alphabet soup at you, but effluent guidelines, I'll say ELGs. That's what I'm talking about, effluent limitation guidelines. You'll also see maybe SEEG, so steam electric effluent guidelines. They're the same thing. This is not a new rule. It's just a revision of a rule that was last revised in 1982. So it was probably time for a revision. This, like other rules, was a court-ordered revision agreed upon. The rule was signed on April 19th of last year, published June, and then comments were finally due September 20th of last year. Duke commented heavily, like I said. We submitted probably 300 some odd pages of comments. The finalized date was supposed to be May 22nd of this year. That was extended to September 30th of next year. So it got about an 18-month extension on that. It's not clear on what the ultimate timeline is going to be based upon that extension, but what you have to understand is it's all based upon your NPDES permit and when it will renew. So even though you got a year's delay, you didn't get a year's delay for your whole fleet. You just got a year's delay for that one guy that missed the window. So you maybe had two guys that moved from the front of the line to the back of the line. The EPA for the rule offered 8 options, so a lot of optionality here. 4 of them were identified as the preferred options. These are the 8 options. So one thing I wanted to highlight on this slide is that what the EPA is doing is defining 7 different waste streams. So they're adding it to other definitions. So an existing definition would be cooling tower blowdown or low volume waste. So now there's new ones that are FGD wastewater, bottom ash transport water, leachate. They're defining new streams. And with those streams comes some sort of technology-based limit. I won't go through all this chart, but the yellow outlines what is the preferred options. And generally, as you go from left to right, generally, it gets more strict. This kind of gives you a view of the preferred options. So you can kind of see some of the optionality here for these lower streams. So fly ash all the way down to non-chemical metal cleaning. There's not much optionality. The optionality exists in the 2 that I wanted to focus on today, which were FGD wastewater and bottom ash wastewater, bottom ash transport water. And generally, again, you can see left to right, it gets more strict. For FGD, you have BPJ, best professional judgment. You know, Duke would not support that for many reasons or consider that as light or lenient. But you go from phys chem system plus bio for units just greater than 2,000 megawatts, and then you eliminate that kind of cap on it as you go to the right. And then bottom ash, basically the continued use of impoundments until you get to that last 4A option, which is the dry handling for units over 400 megawatts. In the rule, besides the waste streams, there's also these anti-circumvention measures. So the first one is probably the most impactful one. Essentially what it says is you can't commingle the streams. You have to demonstrate compliance within that waste category before you move that water into any other category. So you can't, kind of play the shell game for compliance here. Also, you can't transfer effluents from a zero discharge established limit into another. So you can't just send fly ash transport water into low volume waste and say it's treated. And then the last one is sufficiently sensitive analytical methods have to be used. That's critical for things like FGD wastewater, which require dilution. So as far as Duke's comments here, I won't read them directly, but probably the biggest thing is that we feel that internal monitoring points are a bad idea. One, we don't think that they're legal, that the compliance points should be at the point of discharge. We also think that it discourages things like water use or reuse, which to us is a key future for water management at our sites. We'd love to reuse our streams and keep our water consumption down. We feel that this prohibits that. And then probably another big one is the sufficiently sensitive methods. For those who've worked with FGD wastewater, it's very high in TDS, chlorides. I will tell you as learned from experience, don't send FGD water to a lab and not tell them what it is, because they'll probably wreck their equipment. So it requires a lot of dilution. So obviously the more you dilute, the higher your method detection limits are going to be. And in that case, can you measure down to the limits that they've established? And we would tell you, no, you can't. So a typical plant, so obviously I say typical, it's in quotes. So I said that water compliance can be very site-specific because of regulatory issues. It can also be very site-specific because each plant was built differently. It has different just structures. So this is typical for our fleet, probably covers about 80% of it. It's not exactly, but it's close. I haven't put every stream in here, but it's kind of the major ones. So you can see that for the most part, everything kind of ends up in the ash pond. And then we commingle those streams, and then we meet our water quality standards and de minimis thresholds and everything at the discharge to the ash pond. In the future, you're going to take on these internal compliance points, because remember I said you can't commingle any streams until you demonstrated compliance. So you have to meet BAT limits before you can now commingle. So you get all these nice internal compliance points. Picking on bottom ash, again, continued use of impoundment for most options, but now you have to demonstrate a compliance before you can mix it with any other stream. Same thing, again, my focus is FGD wastewater here. We feel that a biological treatment step would be needed to be added, as well as that internal compliance point. And then after all that, again, I won't highlight on the other ones, but you can see them here. After all that treatment and internal compliance points are met, you still have to meet your existing NPDES discharge limits. So you can imagine a lot of compliance monitoring, a lot of process control related to do something like that. So for FGD wastewater, I wanted to go through the options that you have. Duke, again, is kind of a diverse fleet. We have a wide range of options that we've tried for FGD wastewater. So I wanted to go through each one of them and kind of talk about what's good and what's bad. Settling ponds, we have 2 of those in our fleet. Essentially, they're solid settling devices only. You also have to dredge those occasionally. So if you're thinking about, hey, am I going to get something like mercury and selenium, which is the key focus of the rule, you're not going to get that with a settling pond. I would say you're going to get some mercury, but it's going to be the solid mercury. You're not going to get the dissolved. Chemical precipitation, we have 8 of those systems. Right now, those to us, and what we feel is the best path for this rule is they are very effective treatment devices. They get you 95+% there, but according to the process of the rule and the way it was proposed, it's not going to capture your nutrients and your selenium. So it's not going to do everything you need to do. Biological treatment, so these are the bioreactors, the AB Met process, if you're familiar with that. We have 4 of those. Again, they're the ones that are going to get you the nutrients and selenium. They're going to capture that. So you can imagine you got to have the phys chem and the bio in concert to fully comply. Wetlands, we have 2 of those constructed wetlands. Those are designed again to go after something like selenium. One thing for them for effluent guidelines is they require dilution. So our read of the commingling requirements is you're not going to allow to dilute the water coming into it. So again, a major problem there. Vapor compression, evaporation, or some people will refer to it as ZLD. We don't refer to it as ZLD. We refer to it as thermal treatment or a thermal ZLD process if you're going to thermal ZLD. And a funny quick story on that, we were talking to a few folks and they said, well, it's partial ZLD. I said, well, what's partial zero? There is no, so it's really called thermal treatment. High cost, you're talking high capital, high O&M cost here. You're also talking about a huge auxiliary load to your plant. Limited experience with FGD water, so that's a real point of contention in the industry. There's, I think, 6 of them in Italy. There's 2 of them in the U.S. that operate occasionally. We're building one of them at our Mayo facility. I will tell you, again, is the reason why we call it thermal treatment and not ZLD is that it's not ZLD unless you're going to full evaporation, which we do not plan for Mayo. You still have this brine to deal with. You have to find a way to dispose of this brine, which is highly concentrated. So it's a huge challenge. Solids fixation, ZLD, so this is where you're mixing your gypsum and your fly ash and some lime with your water and creating a Positec type material, if you're familiar with that. We have 2 of those facilities running. We're actually constructing another one. We think it's probably a good solution for things like effluent guidelines and future water compliance. The issue is you've got a limited design base that works. It has to balance, so your gypsum and your fly ash and everything all have to come into a nice perfect balance. If you can't do that, you have to do something like concentration with something like a thermal treatment. So again, you're kind of losing that cost advantage there. Bottom line, we think the direction for the rule as proposed is going to be the phys-chem treatment system plus the biological treatment step, unless you have some other reason to build some thermal treatment system, which again, we don't see the need over and above what we're dealing with for effluent guidelines. There are a number of other alternatives for selenium treatment that are out there. The industry is is ramping up pretty quickly. So those are things to watch out for. So these are the limits for FGD wastewater. I won't hit on them, but the key points are arsenic, mercury, selenium, nitrates, or nutrients. The big thing for us is the selenium and nitrate limits were actually set by our Allen and Blues Creek facility. The arsenic and mercury limits were actually set by Miami Fort, so our Miami Fort facility, and then 2 other sites. So again, we felt like we were uniquely positioned to comment on this rule based on the fact that our facilities set some of the BAT limits. So kind of hitting on our comments, we feel and support option 1, which is not a preferred option for them, but we feel that the chemical precipitation or the phys-chem system is the best economic and performance choice to remove pollutants. We also feel that those systems could probably be optimized to perform better, which is also in our comments. We feel that biological treatment and vapor compression evaporation or thermal ZLD are not economically feasible. We also think that the thermal treatment is not commercially available for FGD systems. There's a number of flaws in their calculations. I won't get into those, but there was some method issues that we took issue with. Also, we do not support BPJ options. So that's really leaving it up to each permit writer. And you might say, well, Brandon, why? I mean, for us, you're setting limits. You're setting a rule. You're making a revision. Pick one. We may not like it, but just at least pick one. And we'd rather have that line in the sand than to have a trend by our permit writers to continue to ratchet down. So really, it leaves it open every time a permit is open, it leaves the option of thermal ZLD out there. And we just don't think that's a good idea. So moving on to effluent guidelines and CCR compliance together, I think the nuances between the two, how do they relate? Well, CCRs really focus on the impoundments. So they're really the waste and the dikes, the dams, the groundwater monitoring, those structures themselves, whereas effluent guidelines focus on the water and the water that's discharged. They're certainly separate, but when you look at how you're going to comply, they overlap. And really, you can see CCR is going to lead to ash pond closures, line landfills across fleets. Effluent guidelines, we're talking stream segregation, wastewater treatment, that type of thing. You look at the combined between the two, you're talking dry fly ash, and dry fly ash reliability type projects. So, yeah, a question you should ask is, I might have a dry fly ash system, but does it have a wet backup? It's a big question mark. I think you'd be surprised if you asked. Dry bottom ash, that's another one, and I'll touch on that the next slide. And then facility-wide wastewater treatment, like we talked before. You're going to have to manage things like low-volume wastes in a different way, because you can't just send them to your ash pond. And oh, by the way, have you thought about stormwater? Did your stormwater go to the ash pond? What happens when that ash pond goes away? Big question mark there. For us, what did the effluent guidelines say about bottom ash transport water? Really, again, except for that strict preferred option, it allowed the continued use of impoundments, which we would support. We just don't think that they have the data. They're using data from like the 70s. There's flaws in that data. There's flaws in how it was grabbed. We just don't feel like they have the information to stand on a zero discharge. So we're happy to accept the continued use of impoundments for effluent guidelines, but that still leaves the question mark up for CCRs. So what does that mean for my bottom ash impoundment that I have at the site? So pulling back to this post-ELG, a typical plant, you've got your bottom ash here. I don't know if I do have a pointer. I don't know if anybody would see that. Anyway, you got your bottom ash impoundment. Again, under effluent guidelines, this would be allowed. But what if CCR, and really this is what we're expecting, CCR is going to define what a bottom ash impoundment looks like. Does it have a double liner? Does it have leachate collection? Does it have groundwater monitoring? What if that is, we expect that it's going to basically be an economic decision between retrofitting that existing impoundment or going to something like a drag chain, or a remote submerged fly conveyor. So you see that's your other option if you go to a remote submerged fly conveyor. But if you look, what happened? When I did that, I lost that bottom ash transport water. So as far as my retention pond, it no longer has that, what we would call relatively clean water that helps us meet things like acute standards on the back end of that MPDS permit that still exists. So if you look at this, what are the options you have for dry bottom ash? When I say dry bottom ash, again, I got to put it in quotes because you got to define it. We would say dry bottom ash handling, or we would say dry bottom ash storage. And the reason why we make those definitions is that you've got these options for you. You've got wet storage, which is really an impoundment. Again, CCR may make that cost prohibitive. Then you've got dry storage, which you've got a remote submerged flight conveyor, for those of, that's what it is for those who are not familiar with it, where you're storing your material dry, so it's no longer sitting in an ash pond for days, months, years. It's sitting there dry. But you've got two options with the water side. You can recycle that water. Again, bottom ash is not that reactive. You can recycle that water and keep it going and not discharge it, or you could do a non-recycle mode and continue to discharge it. Again, we think it's very critical to maintain that option, and the reason is that we're going to need it for to meet water quality standards on the back end. Bottom ash sluice water or bottom ash transport water is a relatively clean water. It basically looks, again, depending on contact time, it looks like your background water. It's a good tool to meet things like acute standards on the back end. And what I mean by that is you got an FGD water that's got 15,000 ppm chlorides in it. I don't think the state's going to be very happy if you discharge that to the local river. You need those other streams to mix with it to get that concentration down. Again, we're not playing games with dilution and mass limits. We're just trying to meet those acute standards along with all the others. There is a dry system, is that what we would call that? We see it as very hard to retrofit, so we would try to shy away from it, although we do have one of these facilities at our Mayo plant. In summary here, just my last slide, wrapping it up, effluent guidelines in a nutshell. You're going to have biological treatment, some sort of selenium removal. We just default to biological treatment because that's our experience. For FGD water, right now there's only one supplier for that. So if you're other utilities, we're all going to be competing for that one supplier, or we're going to have to develop new technologies, which the market does have a few emerging that look promising. The performance at those ELG limits, again, this is part of our comments, is that the performance at the ELG limits is not really demonstrated at a wide range of fuels, a wide range of operating conditions. Those limits were set by Blues Creek and Allen facilities that were burning Central Lab coal that basically just sat there and run that coal all day. We went, and part of our flex fuel effort, went and burned some Illinois Basin blends, some Northern App blends, and all of a sudden we saw our selenium numbers go up. So a big issue there. Non-chemical metal cleaning waste, I didn't touch on it much, but you're talking about significant water management issues and operational changes in your plant. Complete, I emphasize complete dry fly ash handling. We're talking new CCR landfills, reliability upgrades if you have a wet backup, and then bottom ash if required, like I touched on, major retrofits to our fleet, and then potential loss of that low pollutant loading waste stream. That's a nice management tool for your MPDS permit. So with that, I'll open it up to questions. How did I do on time? Okay.
You're ahead of schedule, so we have time for questions.
I thought I was behind. That's why I was talking a little fast there. The Italian beef sandwiches put everybody to sleep? No, I'm sleeping.
Jordan to the rescue.
Hi, Jordan Kessler, Department of Energy. My question is, given the timing that they have on the effluent limitation guidelines, and I know that they're shooting for September 30th of next year now, are there concerns over what happens in the final coal combustion residual rule and how that would affect the ELGs, and what would happen if the timing was flipped, if the ELGs were finished first and then the coal combustion residual rule?
It's a great question. I think we would prefer they come out on the same day. But I think if you look at, and really The big question mark for us is how much time is the CCR rule really going to give us to comply? I think our assumption is like 5 years, and that's 5 years to start closure of our ash ponds, which for our active sites we would say is reasonable. If you give us those 5 years, I think, and the effluent guidelines are 6 months later, 9 months later, no big deal. I think we can work with it. I think we would prefer to see the CCR rule first. So we're happy with how it's sequenced at this point. But again, if they came out the same day, that's going to make it easier because it takes the guesswork out of it.
Any other questions?
Ned West from Southern Company. You mentioned, you touched on the challenges of brine disposal from a vapor compression evaporation process. What options have y'all explored on that, and where do you see any success with on-site disposal? Is it classified as a hazardous waste, those kind of things?
Yeah, I think it would pass a T-clip. I think I've worked with a number of folks in Southern on the same issue. We have limited experience, so I would say that we don't have the answers. I will tell you our plan is to mix it with fly ash, so we're going to use that brine for fly ash conditioning, and we're going to landfill it into an adjacent monofill. But we're worried about the leachate that comes off that. The plan now is to continue to kind of recycle that leachate, and then on the landfill itself for dust control, and then in heavy rain events or whatever, we would send it back to the thermal treatment system and run it through the process again. I know there's been a number of studies. We've done studies, EPRI's done studies, UNC Charlotte's done studies. I would say a lot of them are not very positive about using just fly ash to contain the halogens. So I think we have a short-term plan. I think that short-term plan is going to give us an ability to come up with a long-term plan, if that makes sense. Great question, though.
I'm going to exercise my prerogative to ask one question. One of the things that we heard a little bit about this morning was, indirectly, was cost. And this is a whole different set of costs that will be layered on. You're in different markets. There's regulated versus restructured versus what have you. Setting that aside, what do you estimate some of the costs of compliance are going to look like? And I know you don't have an exact dollar figure, but if you've got a range of high, low, or if the rule goes according to what you think it may be, what does that look like? Because it's an former economic regulator, and as Chairman Quackenbush is still an economic regulator, we're obligated to pass those costs on in some way or another to ratepayers. What's that going to look like?
I can speak for Duke, and I do know the exact number for Duke, but I just can't tell you guys. So I'd love to, but I'm responsible for that number, so I know it. Right. The number for the Duke fleet, and again, your big cost, maybe I'll talk about the big cost. Sure. The big cost is FGD wastewater and then a non-chemical metal cleaning waste. So when you wash an air heater, a precipitator, you have to now treat that water. Do you use a permanent system or do you do some sort of temporary setup? You know, again, or you use some sort of fleet solution. Those are the type of things that we're looking at for those. But that's the big cost. Stormwater management is going to be another big cost. If you look at Duke as a fleet, we're estimating costs between $700 and $1.5 billion for our fleet for effluent guidelines. Now, there's some overlap with CCR, like I said, but generally that's the water management piece of it. I don't know if that gives you a kind of a context, but I would tell you at a coal plant, maybe call it a 2-unit facility that, generally meets the typical aspect of what I laid out, you're talking $30 to $50 million. Yeah, for the site. That's probably a fair number. Does that help everybody?
I have one more question just here.
David Heath at Dynegy. You're talking about $30 to $60 million for facility. When you look at building a landfill to contain your fly ash and your bottom ash, I would say that you're looking at several $1 million a year in the capital cost to build that landfill, and then your O&M cost to handle that ash and place it, whether you mix it with something else to condition it or not. But I would say your cost, based on our experience, is way understated.
That's a fair point. I mean, really what I was talking about was related to the water treatment, so it's not the landfill cost. I don't have the landfill costs on the top of my head. So to clarify, just the water treatment, replumbing, things like retention basins and ponds, that's factored into that cost, not the landfills. But I agree with you 100%. You're getting into millions of dollars a year and tens of millions over long periods of time. And, just a little small editorial, we talk about that, you think about ash ponds. It's like ash ponds, you've been storing that ash there for years, sometimes decades. Well, now on a cost basis, on a dispatch price basis, you're talking about real-time disposal of that ash now. So everything, your costs in real time now went up. You don't have a deferral cost, if you will. So excellent point. Thank you. Any other questions?
Any others?